Hello. Today I'm going to show you how to draw Lewis structures for simple molecules, double and triple bonds. When you have your notes, you have the list of the steps that I'm just going to refer to this whole time, and then make sure you follow along and draw the pictures with us. All right, so we're going to start on page 4 with NF3. All right, so first step, we're going to add together the number of valence electrons for each atom in the molecule. All right, so nitrogen has 5 valence electrons, plus fluorine has 7 valence electrons, but since there are 3 of them, we're going to multiply that by 3. So we get a grand total of 26 valence electrons. Okay, step 2. Write out the elements in the molecule so that the least electronegative element is in the center, surrounded by the other elements. Hydrogen is never in the center. Okay, so for this example, nitrogen is in the center because it's less electronegative than fluorine, surrounded by 3 fluorines. Doesn't really matter where you put the F's as long as you have 3 coming off of nitrogen, it doesn't matter. Okay, step 3, place a covalent bond between the center atom and the outside atoms. Remember, each bond contains 2 electrons. Step 4, subtract the number of electrons we just used from our total. So we have 2, 4, 6 electrons we just used. So we have 20 left. Okay, we're still on step 4. Put remaining electrons around the outside atoms as lone pairs to satisfy the octet rule, except hydrogen. Hydrogen only needs 2 electrons. Okay, so let's start with this fluorine. It already has 2 electrons, so we need to put 6 more so that it has 8. And they're going to be dots. So 2 on the top, 2 on the side, 2 on the bottom. That fluorine is now surrounded with 8. Okay, now the bottom one. It already has 2, so we're going to put 2 on the side, 2 on the bottom, 2 more on the other side, so now he has 8. Last fluorine, 2 on the top, 2 on the side, 2 on the bottom. Okay, count up how many dots that we just used. So we have 18 dots, so we're going to subtract that from our total. So we have 2 more valence electrons we need to place. So we're on step 5. Put remaining electrons around the central atom as lone pairs. So we have 2 electrons left. We're going to put them on nitrogen. And we're going to put them on the top of nitrogen. So 1, 2. All right, we have now placed all the dots. We have no more electrons we need to place. So now we're ready for step 6. Check all atoms in the molecule to ensure that each has 8 electrons, except hydrogen. If an atom has fewer than 8, make double and triple bonds. Okay, so let's check. Fluorine, 2, 4, 6, 8. He's good. The other fluorine, 2, 4, 6, 8. The last fluorine, 2, 4, 6, 8. It's good. Now check the central atom. So nitrogen, 2, 4, 6, 7, 8. So he's good. All right, so let's do the next one. Let's do water. All right, step 1, add together the number of valence electrons in each atom. Okay, so we have hydrogen, which has 1 valence electron, but we have 2 of them. So we're going to multiply that by 2. And then oxygen has 6 valence electrons. Add that together, you have 8. Okay, write out the elements in the molecule so that the least electronegative is in the center. Hydrogen is never in the center, so we have hydrogen. It cannot be in the center, so that means oxygen has to be in the center. Okay, so we have 2 hydrogens that we need to place on the outside of oxygen. It does not matter where they go. I like to keep mine in a linear fashion, but it does not matter. You could draw one of the hydrogens coming off the top and the side, or the bottom and the top. It doesn't matter. Step 3, place a covalent bond between the center and the outside ones. Step 4, subtract the number of electrons we just used from our total. So 2 here, 2 here. So that's -4. Okay, so we have 4 electrons left. Put remaining electrons around the outside atoms as lone pairs to satisfy the octet, except hydrogen. Hydrogen only needs 2 to be happy, and he already has 2. Okay, so we cannot put dots on hydrogen. Never put dots on hydrogen. So that takes us to step 5. Put remaining electrons around the central atom as lone pairs. Okay, we have 4 electrons left, so 2 on the top, 2 on the bottom. Okay, now we are all out of dots. Step 6, check to make sure everybody's happy. So hydrogen's happy with 2. This hydrogen's happy with 2. So look at oxygen. 2, 4, 6, 8. So he's good. Okay, let's do the next one. CF2Cl2. All right, so this one's kind of crazy because it has 3 different elements, but it's no big deal. Okay, we just do step 1, we add up all the valence electrons, this is like normal. All right, so carbon has 4 valence electrons, plus fluorine, so 2 times 7, because we have 2 fluorines, plus chlorine, which again is going to be 2 times 7. So our grand total is 32. All right. Write out the elements of the molecule so the least electronegative is in the center. Also, pretty much carbon, if you have carbon, he's always going to be in the center. Okay, so we have carbon, so he's our center guy. All right, we have 2 fluorines and 2 chlorines that need to come off of carbon. Again, it doesn't really matter what air location you put them in. I like to keep my fluorines linear from each other, and then I like to do the chlorines on the top and the bottom. Put your covalent bond. Subtract the number of electrons we just used, so 2, 4, 6, 8. 32 minus 8 is 24. Place remaining electrons on the outside atoms until they're happy. So let's start with the fluorines. He already has 2, so 3, 4, 5, 6, 7, 8. The other fluorine already has 2, so I'm going to add 6 more. The top chlorine already has 2, so I'm going to add 6 dots. Has 2, so now I added 6 more dots. Count up the dots you just made. We just made 24. All right, we are completely out of dots. No more dots, so we're ready for step 6. We can skip step 5, so we're going to step 6. Make sure everybody's happy. 2, 4, 6, 8, 2, 4, 6, 8, 2, 4, 6, 8, 2, 4, 6, 8, and then check carbon. 2, 4, 6, 8. Okay, let's do the next one. CS2. Step 1, add up all the valence electrons. Carbon has 4 valence electrons, plus sulfur, which has 6 valence electrons, but we have 2 of them. So we're going to multiply by 2. So 16 total. Okay? Center atom, it's going to be carbon. Pretty much anytime you have carbon, it's going to be the central atom. And then we have 2 sulfurs that we need to drop. Again, I like to be linear. So I like to put my sulfurs across from each other, but you can do one on the top, one on the side, it doesn't matter. Add your covalent bonds. Okay, step 4, subtract the number we used. So 2, 4. Okay, we have 12 left. Put your remaining 12 on the outside atoms. So sulfur already has 2, so we get 6 more. This sulfur already has 2, so he gets 6 more. Okay, so that's 12 dots. We are out of dots. You cannot draw any more dots. So we can skip step 5. Now we need to go to step 6. Check to make sure everybody has 8. Okay, so the sulfur, 2, 4, 6, 8. The other sulfur, 2, 4, 6, 8. Now the carbon, 2, 4. Okay, the carbon is not happy. We have no more dots to place, so we have to start making double bonds. All right, so here's what happens. The sulfur on the right looks at carbon and goes, oh, poor baby, you don't have 8. Here's what I'm going to do for you. I'm going to take a pair, one of my lone pairs, and share them with you into a double bond. This sulfur is still happy. 2, 4, 6, 8. Let's check to see if carbon's happy yet. 2, 4, 6. He's not happy yet. So the other sulfur goes, oh, poor baby, carbon, you're not happy yet? Here's what I'm going to do for you. Take one of my lone pairs and double bond with you. So now this sulfur is still happy, 2, 4, 6, 8. Now let's check our carbon, 2, 4, 6, 8. He is now happy. Okay, let's do the next one, CO. Okay, carbon has 4 valence electrons plus oxygen 6, 10 total. Okay, carbon's our central atom, bonded to 1 oxygen. I put my oxygen on this side, you can put your oxygen on the other side, it doesn't matter. Subtract the number we just used, so subtract 2. We have 8 left. So since carbon's our central atom, let's make oxygen happy. So 1, 2, 3, 4, 5, 6. We have 2 left. They're going to go on carbon. Okay, we are totally out of dots. Now you have to check to make sure everybody's happy. Oxygen, 2, 4, 6, 8. Good. Carbon, 2, 4. He's not happy, so we have to start making double bonds. So oxygen, who is happy, goes, oh, carbon, poor baby, I'm going to make you closer to being happy. So oxygen takes one of his lone pairs and makes it into a double bond. Oxygen's still happy, 2, 4, 6, 8. Carbon, 2, 4, 6, not quite happy. So oxygen says, oh, carbon, you're so needy. Here's what I'm going to do for you. I'm going to give you another pair to share with you. So he had to take 2 of his lone pairs to share with carbon so he could be happy. So 2, 4, 6, 8. Okay, let's do one more. Diatomic selenium. Se2. All right, so selenium is in group 6A, but we have 2 of them, so 12 valence electrons. Okay, so we have 2 seleniums bonded to each other. Anytime you have 2 elements of the same, I would kind of designate one to be your central atom. So I'm going to say the selenium on the left is my central atom. So I just put a little star there so that I remember. Okay, so I drew my picture, I drew my covalent bond. I'm going to subtract 2. So I have 10 left. So I'm going to make my outside selenium happy. 3, 4, 5, 6. So that means I have 4 left. So those go on my central atom selenium. Okay, so I'm all out of dots. My central atom selenium is not happy, 2, 4, 6. So the happy selenium is going to go, oh, poor baby, here's what I'm going to do. I'm going to take one of my lone pairs and share them with you. So selenium, 2, 4, 6, 8. The other selenium, 2, 4, 6, 8. All right, I hope you enjoyed.